Welcome to AI Podcasts, and today we're digging into a NeurIPS 2025 paper called Automated Composition of Agents, a knapsack approach for picking the right components.
Give me the headline first. What's the one thing listeners should remember?
In one line, the authors say you should build an AI agent the way you pack a backpack. You've got limited budget and space, so you test what actually helps and only carry the items that earn their keep.
Knapsack, as in the classic algorithms problem, where you choose the most valuable items that fit in the bag?
Exactly. Here the items are tools or subagents. The value is how much they help on the task. And the weight is their cost in money or tokens or latency. The twist is that you don't trust descriptions or embeddings alone. You quickly try candidates in a sandbox, estimate their usefulness, and then accept or reject them using an online rule from the knapsack literature.
All right, before we go deeper, who drove this work?
The paper is largely by Yuan and Khushbu Pahwa, with a team from AWS, and Yuan is now at Oracle AI.
Got it. So what problem are they solving that existing systems haven't nailed?
When people build agentic systems, they face a wall of choices. There are dozens or hundreds of tools and subagents that sound similar on paper. Traditional approaches often pick tools by semantic matching or by reading the tool's description. That sounds tidy, but in practice, the descriptions can be outdated, noisy, or just too optimistic. Plus, you rarely get a clean way to trade off success against cost.
Right, and real tasks shift. Today it's travel planning, tomorrow it's filing a mortgage application. Static metadata can't keep up.
Exactly. So the authors formalize the decision as knapsack under uncertainty. We want the subset that maximizes the chance of solving the task without blowing the budget. But since we don't know values ahead of time, we probe the tools first.
Let's unpack the approach step by step. How does this composer agent actually pick components?
First, it translates the user goal into a set of skills. Think of skills like web search, itinerary generation, currency conversion, or document parsing. For each skill, it retrieves a short list of candidate tools based on embeddings, but that's just to narrow the field.
So retrieval is the starting gate, not the finish line.
Exactly. Then comes the key move, tiny sandbox trials. The system generates one or two micro questions per skill, calls each candidate tool in a safe environment, and asks an LLM judge whether the tool improved the partial solution. From that, it computes a simple value-to-cost ratio.
And then the knapsack part decides which ones make the cut.
Yes, it applies an online thresholding rule. If a candidate's value per unit cost clears the bar and there's budget left, it gets added. If not, it's skipped. The threshold adjusts as the composer sees more candidates, which helps it avoid spending early on mediocre options.
That feels like packing for a long weekend? You start with essentials, and the more you pack, the pickier you get.
Perfect analogy. They also compare this to a few baselines. One is the identity setup that includes everything, which is expensive and overwhelms the planner. Another is retrieval only, where you pick the top match by similarity. And there's an offline knapsack variant that trusts retrieval scores as values without doing the live trials.
All right, I can picture the single agent case, like a travel agent choosing tools. What about selecting teams of subagents?
They test that too. Imagine a larger workflow, say a mortgage process, with specialized subagents for document collection, risk checks, and communication. The inventory can have more than 100 subagents. If you plug them all in, the supervisor gets noisy handoffs and decision paralysis. The composer instead assembles a small, budget-constrained team by running those same light probes and applying the online threshold.
So you end up with a lean roster that actually plays well together, rather than a stadium full of benchwarmers.
Exactly. In their comparisons, the online composer tends to land on the sweet spot where accuracy improves without spending more. In other words, it finds configurations that dominate the baselines on the accuracy versus cost curve.
Can you make this concrete with an example?
Sure, suppose you're building an agent to plan a week in Tokyo. Retrieval might choose a fancy booking API because the description sounds great. The sandbox, however, could reveal that a simpler web search tool plus a currency converter beats it for this budget in this query mix. The composer sees that those two tools consistently help in the micro trials and they're cheap, so it takes them and rejects the flashy but brittle option.
That's nice because it's grounded in measured behavior, not marketing copy.
Exactly the point. The author's narrative is that measurement changes the game. Tiny targeted tests let you estimate real value, and the knapsack lens gives you a principled way to say yes or no under a budget.
What about the modeling details we usually skip but matter in practice? Any assumptions we should keep in mind?
A few. First, some experiments estimate tool costs rather than billing real APIs end-to-end. That's practical but may underplay rate limits, retries, or tokenization quirks. Second, in the multi-agent setup, they simplify by giving each sub-agent the same cost. That isolates the selection algorithm, but real services are more heterogeneous.
So results are directionally useful, but the exact numbers might shift in the wild.
Right. There's also overhead. Those sandbox trials add setup time before you deploy the assembled agent. It's a sensible trade if you reuse the configuration, but it's not free. And like any system that leans on an LLM judge, you want to make sure the judging prompts are robust and don't reward hacks.
Any notes on scope or reproducibility?
They evaluate on a handful of single-agent benchmarks and a couple of multi-agent domains. It's a good spread, but not exhaustive. Public assets like tool inventories or judging prompts would make it easier for others to reproduce and extend.
Let's flip to implications. If I'm an engineer building agents, how does this change my workflow?
Two shifts. First, stop treating tool selection as a one-shot retrieval problem. Treat it as a brief experiment loop. Generate a few probes that reflect your use case. Measure how candidates help and keep only the ones that pay their way. Second, be explicit about a budget. Even a soft budget forces cleaner trade-offs.
And what about the future work the paper nudges toward?
Great question. 3 directions stand out to me. 1, go beyond additive value. Some tools are better together than alone, and some clash. Modeling those interactions would make selection smarter. 2, learn the acceptance rule from experience. Instead of a fixed threshold, use bandits or reinforcement learning to adapt what you consider good value for money over time. 3, evaluate with real costs, including latency and rate limits, so budgets reflect production reality.
I'd add a governance angle. If composing gets faster, you need checks so a newly added tool doesn't sneak in unsafe behavior. Vetting, provenance, and allow lists help here.
Absolutely. The same machinery that tests for utility can run guardrail probes too. So selection is about usefulness and safety.
Quick recap then. This NeurIPS paper reframes agent building as packing a backpack. You estimate the usefulness of tools or sub-agents with tiny trials, then pick a set that fits your budget using an online knapsack rule. That beats relying on descriptions alone, and it tends to get better results for the same or lower cost.
And the caveats are clear. Some costs were simplified. The judging step adds time, and broader open evaluations would help. Still, as a design pattern, measure first and then select under a budget feels like a solid upgrade to how many of us assemble agents today.
All right, last word for listeners who want to try this on Monday morning.
Start by writing down the budget you care about, even if it's rough. Generate a handful of probes that look like your real tasks. Trial a small pool of candidate tools. Keep the ones that consistently help, and don't be sentimental about the rest.
Light backpack, stronger hike.
Exactly. This is AI Podcast. I'm Ethan.
I'm Maya. Thanks for listening, and we'll see you next time.